Hi. Um, hey. Hi, coffee. Good morning. What's up? Testing. I think I can be heard. Okay. This was supposed to be my Halloween costume, but apparently could not stream on Halloween. So I was like, the day after Halloween works as well. Or maybe it's still Halloween, probably somewhere around the world. Not that I care. It's just fun. Like I like the fact that now most movies are spooky. Um, yeah. Okay. Hello. Hi. Um, Apologies for the issues yesterday. I mean, I'm still streaming late. If you can believe it, my main issue right now is the HDMI cable. It is not good. It's currently working because there's a Kleenex tissue under it. It's holding it up. So huh? Oh, really? Shoot. I I'm mixing Halloween and Christmas. I thought isn't it 25th? It's the 30th? I'm gonna Google it. I, Halloween, how is it written? Halloween date. Better be 20. Oh, it's 31st. Wow. Well, I thought it's 25th. See, that's how much I care. Apparently Halloween is next week. So expect more spooky costumes. Yeah. It's mostly variations of this hat with different colors. Today's color is Spooky Ghost. Okay. So I have no idea where I was. It's not a date that I care about as much. It's never like it's not I mean I get that we care about dates, but does it matter? Like is it a big deal? Um I don't know. Uh ah I mean it does, doesn't it? Does it? Do they match? No. Um I'm like, can they be equal? Why not? Put three equal signs and maybe that's true. Ah, I didn't know that. Thank you. I also like the hat. Not made by me, that's for sure. It doesn't look well with the background. Let me find a better background for my cute hat. See? Um, hello. Yes, hi. Hello, Aitsuki. Yeah, double checking that I'm saying your name correctly, and I think I am. I hope that I am. To play on the month abbreviation. Ah, so could yes. Hmm. 21st October. You're right. That's a good one though. Like the octal and decimal. My brain didn't go there. Um, Yay! I said it correctly. It's a nice name. Yeah. Okay. I am here. Okay. I remember. I mean, I don't remember. I just saw my cursor highlighting something here, so now I have to be here. All right. Alrighty then. What's happening? How many models have we done already? If I go to like how many codes have I copied? That might be a better question. And it's a lot, honestly. But number of models, it might be under 10. I don't think it's over 10. Yeah, because even in this main tasks part, one about token classification, one, is that translation? No, that's translation. This is summarization. What was this one? Oh, masked language model. Yeah, These are all like tasks, and then each of these had at least one. Yeah, maybe it's like 10, around 10. And personally myself, like without needing to stream it, I've probably tried to test a few. Yeah, fun stuff. I need to rerun this because it loses the session each time. So I'm gonna say I probably need to double check the runtime. GPU. Merci. And then run before, and then we can see what we can do. Do I have finished personal projects? The answer is it's never like fully personal projects. It's me using other people's things. But probably like 2 to 3, yeah. Like that work, you know? I wouldn't call them finished because you can still deal with them. But yes, like maybe 2 ones that I'm happy with. And work, and I can like use the API from HuggingFace, something like that. Yeah, 2 or 3 maybe, because it's like I find blogs that people work on the thing that I'm interested in, and I try to follow it and use a different language. That makes it my personal project. Yeah, like this is a change that I add to it, because or like sometimes YouTube videos, but those are really difficult to follow. There might be like 5-6 YouTube videos that I've tried to follow that I have failed. So I was like, if I ever make a tutorial, I'll have to be as transparent as possible, which I guess I have made tutorials. The hash code ones. I've tried to like put all of my code on GitHub, show as many steps as needed, because the person who's watching it can speed it up or go back and go forward or whatever. So yeah, I tried to show the whole process. Because even the ones that have their code on GitHub, I still sometimes have problems running the code. Yeah, indeed. Yeah, not great at the moment when you're doing it, because I always get frustrated. Like I get frustrated too easily. It's unhealthy. I was taking my friends somewhere the other day, and they were like, "Oh my God, you actually like is the word frustrated good?" I don't know if the word frustrated is good, but they were like your driving is fine, but you get yeah, I'm gonna use the word frustrated. I can't find a different word. Because they were like, "Look at my screen while you're driving," and I was like, "I'm not gonna do that." So they're like, "I sometimes do that." I said, "I don't." If I need to look at the map, I can, but if it's another person showing me, then then it's not easy, because the target might be moving. Yeah, anger management, honestly. Attention, sure. Attentive, maybe. No, but that's a positive word. I'm looking for a one where you get yeah, like easily distracted and frustrated by it, something like that. I don't know. Anyway, I do have an anger management issue, like for real. I do get angry easily. Okay. Thank you. Maybe. Yeah. It's just when you plan for a day and then the day goes awry, that's the part where I get like, oh my God, what should I do now? And I'm just trying to work on that. Like not everything is going to go according to plan, you know? Yeah. Yeah. That's why I try to live in my bubble as much as I can and not, that's why I don't have friends. Like seriously. It's positive. You are looking for a positive word. No, not really. Yeah. Yeah, no, it's something that I need to work on. Even though for driving, I don't think it's a negative thing to focus on driving and not look at the person next to you. phone, even though it's a map. They can read the map. Anyway, yeah. So I'm gonna try and run this. Yeah. You know, there are people who get angry easily and get like fine easily again. Like they are okay. They make up easily. I'm not that. Yeah, it's unhealthy. But again, I recognize that about me, so I try to not do that. Yeah, like I have so many examples where I'm like, okay, I am currently about to get angry right now, so I'm going to shut my mouth and not react. Like I can recognize that. Like a kettle boiling, you know? Anyway. Yep. We are working on a GPT-2 model, which is I guess open source, right? Because the weights are publicly available. We'll use the same configuration for our model as for the small GPT-2 model. What is our model? We're initializing one, right? Isn't that well trained? We're fine tuning them. Fine tuning a GPT-2 model on a task that we want, aren't we? No, we're not. Okay, sorry. Are we? To freshly initialize the GPT-2? Maybe we're doing this for okay, we're copying its config. That's how I see it. So we load the pre-trained configuration, make sure that the tokenizer size matches the model vocabulary size, and press the BOS and EOS. Pass. There we go. You are able to identify your anger coming and you stopped it. Not always. There are times where you say things that you regret, which is not nice. Yeah. EOS and beginning of sentence and end of sentence. Okay. We pass these on. Oh, there's something that I need to say. Okay, right? Is that why it stopped? No? No. Uh-oh. What is that? Loading? Didn't I stop running this last time? Because it's too much. This is the smaller version. All right. Yeah. Yeah, you're right. It's just you can redirect it, use it for something else. Yeah, mitigating anger. I don't know how to do that, honestly. Yeah, I have, no joke, I have tried looking up anger management videos and seeing, cause yeah. Yep, okay. But yeah, I think just trying to, I guess I'm pretty avoidant, but like trying to avoid situations that will make me feel that way. Is that avoidant? I don't know. Yeah. If you guys have better strategies, let me know. With that configuration, we can load a new model. By the way, I think I fixed the Discord notification thing, so thank you, Coffee, for that. I still need to make sure that it's good, but yes. We're still getting double notification. I don't know if that's a good thing or a bad thing, but yeah. It looks nicer at least. So thank you for that. So loading a new model? What does that mean? This is the first time we don't use the from pre-trained, I know, function, since we're actually initializing a model ourselves. So we're copying. Yeah, thanks. We're copying models, parameters, weights, and stuff, configuration. You're still running. Oh my god. Okay. It's already loaded. No. No. Okay. So we're saying take this config and do what with it? This is like GPT-2, okay. Our model has 124, I'm guessing, million parameters that we'll have to tune before we can start training. Okay, so we're starting with a base, but we are editing the base. We need to set up a data collator that will take care of creating these batches. Okay. What was our data? The parrot. What was our data? Oh my god, I forgot. Parrot. GitHub. Oh, we're we're creating a model that finishes code for you, like Copilot, but worse. That's the idea. And we have currently put everything next to each other so that the what is it called? The indentation is gone, I think, yeah. We can use the data collator for language modeling collator, which is designed specifically for language modeling. Okay, got it. Wow, thank you. As the name subtly suggests. Besides stacking and padding batches, it also takes care of creating the language model labels. In causal language modeling, the inputs serve as labels too, just shifted by one element. Okay. And this data collator creates them on the fly during training, so we don't need to duplicate the input IDs. Did I know that? I feel like I didn't know that. Note that this supports both masked language modeling and causal language modeling. Masked language modeling models also fill in the blank for you, right? So those two are like very similar in function. Yay! Finished? Not fully. Okay. Few more minutes, 5 more minutes maybe. So by default, it prepares data. So by default, it assumes it's a masked language model thing. And we can switch to CLM by setting the argument MLM to false. Yes, like it's more generative, right? Next token, but like, isn't the idea pretty similar? Maybe it's not. Like, fill in the blank versus tell me what's next. It's just that in one, it doesn't know the future. In one, it does, right? Like what the full context of the sentence. So we have our pad tokens, which is the end of sentence token. And then we're saying this is not an MLM. The word MLM in my brain stands for multi-level marketing. Let's train our brain to think of it as masked language model. Let's have a look at an example. Oh, but we're not ready yet. A few more minutes. I'll have to run this code when it's finished running. So we're just taking 5 from our training, and moi, what? I thought it's 1 to 5. Doesn't seem like it. I'm seeing 1. Anyway, shape. Oh, we're looking at the shape of the input. We're looking at, we're looking at key, not value. So the shape of the input IDs and the attention mask and the labels are the same. I guess that's what we did this for. You can see that the examples have been stacked and all the tensors have the same shape. Yeah, that was what we were looking for. Shifting the inputs and labels to align them happens inside the model, so the data collator just needs to just copies the input to create the labels. Cool. I don't know what that means, but thank you. Now that we have everything in place to actually train our model. Okay, is this called pre-training? Because I feel like it's not. We already have things initialized, don't we? That wasn't so much work after all. I mean, I haven't done anything yet. So if we all attempt to stream our learning where you're downline and we have yes, that's the idea. Yeah, you have to pay commission, and then you have to also have other people do this. That's a good one. Or even if you train your model, you have to pay a commission. And my model has to be like the base, the pre-trained version. And then someone has to use your model as a that's very much MLM. Yeah. Before we start training, we should log into HuggingFace. Cool. This will display a widget where you can enter. Yep, we got it. I'm not gonna do that, but yeah, because we're not ready yet. Oh my god. These are so many arguments. This is so like custom. All that is left to do is to configure the training arguments, and my I guess fear when it comes to training a model is how will I know what is the best argument? And obviously you don't unless you do something that another person has done, like copy and paste. And like you have to do at least a few to see what works, right? Am I wrong? For example, learning rate, and what else? Just like how many steps, how many epochs, all of that. That is very scary. Oh, hydrate. And oh my god, I am sitting like a goblin. Check, thank you. There we go. Why am I not getting the notification again? I swear I checked. Thank you. Okay. I have coffee with me, not water. But I did have 1 full glass of water after I woke up because like I cannot survive without water. Thank you. Wait, before I do that, I need to emote as if I am drinking water. Here we. Oh, where is it? Wait, did I remove it? No. Oh, there it is. No, not it. Oh, there it is. Found it. Why is it so far? Oh, you can't see it. Whoops. All done. And now I'm distracted by the poses that are in front of me, trying to find one that is normal. No. I don't only drink water. I'm drinking coffee right now. But I also had ayran yesterday, which I love. I'm actually trying to plan my drinks. Like, I love coffee, so I have like 2 a day. Like I have yeah, paced myself that way. Because I used to drink 3 cups, and my cups are not normal cups. They're tumbler sized, or yeah. So um yeah. So I now drink ayran and tea. I also drink tea. Um 3 cups of, yeah, like big mugs, like big cups. Because when I drink tea, the cups are much smaller. Because I'm used to it that way. Have you guys seen the Turkish tea things? What are they called? Tea sets? Oh, ayran. Yeah, that's one. Well, actually, I don't mind drinking ayran whenever. That's just, yeah, yogurt drink. I can have one in the morning, one in the, like, even evening. I don't mind it because it's just yogurt. Um, and I would like to think that it's healthy. Yeah. Um, I still want to show you that Turkish tea. What is the cup? There we go. It's still called a cup. I don't think this is a cup. How dare you call this a cup? um, can you see it? It's pretty small compared to like a mug or something. I mean, I don't drink out of these. These are like fancy, and don't have a handle. I like handles more. But yeah, they don't hold so much, which is a good thing, and look beautiful, don't they? Um, yeah. Wow, I've seen these. They're way too fancy. They have like a header, or see? Oh my God, it's beautiful. Um, like it has. They have a hat. This is for coffee. This is not for tea. I will stop. Um, yeah, they are beautiful. Looks like a pain when doing dishes. It is not easy. You cannot fit your hand to it like you would a normal cup. But no, not too much pain. It's a normal amount of pain. Depends on how fancy it is. But yes, especially, my God, this does not matter at all. But especially if there is sugar at the bottom. But you can just rinse it out. I'm talking as if I do dishes every day. I don't do chores. I'm a useless person when it comes to that. Um, okay. Where? Okay. Oh my God, it's ready. Finally. So for the training we have 1, 2, 3. Oh, 1,300,000. This is the version that is updated. What did we do to update it? Page, I think. Yeah, because the size used to be different. Yeah, 50,000 became 1,000,000 because, yeah, because we did the splitting and the padding and everything. And now we get the config, and then we check for, okay, we check for size, which is the same size, nothing has changed. Yeah, and then for the shape, should be the same shape. Again, nothing has changed. Yeah. I'm also trying to drink healthy ayran and not add sweeteners. And I have done that the past few days. So, yay me. Login. We need to fix this login. So, I think we just use the word login instead of notebook login. And then we do, oh, shoot. I'm gonna now do this face, this screen, while I try to copy HuggingFace token into our login, which actually is currently not showing anything. Oh, there, now it is showing. See, sometimes it does. Oh, my bad. Got it. Okay. So this is how it works. You take this, and then you take one of your tokens, put it under this secret thing, and then you use that, which is really nice. And then if I run it, it will say, do you give permission? And I say yes. Oh, it didn't say that. Okay, apparently I've already given permission. Now we are at the argument thing. So let me see what we're doing with the arguments. All that's left to do is configure the training arguments and fire up the trainer. We'll use a cosine learning rate schedule with some warm-up. What does that mean? What does warm-up mean? And an effective batch size of 256 per device train batch size times gradient accumulation steps. Gradient accumulation is used when a single batch does not fit into memory. And incrementally builds up the gradient through several backwards and forward passes. So it goes back and forth. We'll see this in action when we create a training loop with accelerate. Okay. All right. All right. So DS. What does DS stand for? So this is our output directory. Batch size for training, batch size for eval, and then steps, and then steps, also steps. I feel drinks and stuff are just less enjoyable without sweetening. That's your opinion. But I like artificial sweetener in my tea and stuff. I now cannot drink sweet tea. I used to be a serious sweet tea drinker, and then I stopped adding, like I gradually stopped adding sugar, and then I could not drink the tea anymore. And because I was no longer adding sugar, and then because I even took out sugar out of my coffee because milk, I feel like cream milk, whatever, is like the equivalent for me. And then I got back into drinking tea, but very watered down, because black tea is heavy. Yeah. Yeah, I also like sweet things, but I'm trying to like not, because your body is, what you train it to do. We are like a language model. They say kids are like paste, you can make whatever out of them. So your body is literally the same. If you get it used to having, drinking sweet stuff, then it will get used to it. If you give it a few days or maybe weeks, probably like more than a month of bitter drinks, it will be happy when you give it a drink that's not bitter. Your taste buds get used to it. Like I really cannot have sweet tea right now. Like I used to love it, and now if I drink, sometimes like a kid tells me, is it, have my tea, check if it's too warm or not. And I become like queasy, not queasy, but you know what I mean. Like it's annoying. So you will get used to it, but you have to like put in the work. And for me, putting the work was no longer drinking tea because I thought I cannot drink it. And then I got back into drinking it like past 2 years. We are spilling the tea today. What are your favorite teas? I also like green tea a lot, like chamomile, jasmine. Mint is a bit basic, but oh my god, lemon and ginger. What else? Yeah, I have like a cupboard of. Yes, I don't have as much now because I'm for some reason not drinking enough green tea, which I should get back to it. Yeah. It's a bit, I'm not cheap, but it's a bit pricey. But I always have it. Coffee's also pricey, actually. So yeah, if I'm worrying about price, yeah, at least green tea is not evil pricey, you know? Have you guys heard that it's possible that we'll run out of coffee in the next 50 or so years? That I don't like. We can just start the trainer and wait for the training to finish. Oh, right, I'm supposed to start the trainer. Got it. Earl Grey is like the most common flavored tea in Australia. Tea with stuff added. I've probably had Earl Grey, but it feels a bit artificial to me because we buy blended tea. But yeah, climate change is pretty depressing. I don't like having tea bags, you know, like teas inside tea bags. Yeah, because I never know when it is when to take it out. Or then I want to use it multiple times. But normal tea is just in a pot and you pour the enough that you want and that's it. Oh my God, look. We can start the trainer, wait for it to finish depending on whether you run it on full or subset. I'm using subset. It will take 20 or 2 hours. So this should take 2 hours. Grab a few coffees and a good book to read. That's good advice. Yeah. I'm probably gonna pause here. This is like way too easy. I feel like we did nothing. Ya Allah. Okay, sorry. A sound from the outside. Can't tell if it's far or near. Sounds are weird. After training completes, we push to hub. Got it. And then it took about 30 lines of code in addition to the arguments to get from raw text to training GPT-2. Try it on our own data set. What data set do I want? If you have access to a machine with multiple GPUs, I do not. Yeah. No way, trainer manages multiple machines? That's so cool. There are some attempts to, what does this mean? Hybridize coffee to different conditions. Make it get used to different conditions. It might be like with bananas where bananas are scary. We just have to get used to it tasting a little. Oh my God, you're right. But stays available. Okay, that would be nice. But the scary thing about bananas is that we're using the same banana. Like we've been using the same banana for so long, and if this goes bad, like if this strain, like dies, we're out of bananas. Or maybe like the current banana. Maybe we can do something with it. Okay, yeah. The noise is inside, not outside. Got it. Okay. Yeah. Bananas are scary. I'm sure like you guys are on the internet. You've seen the yes. What am I supposed to hit enter? Got it. How many times? Eh? Wait, what is happening? Quit? Wait, why are we using weights and biases and you didn't even tell me to create Wait, if I quit, does that mean it just stops everything? I don't wanna. I guess I'll have to log into weights and biases. Okay. I'm gonna authorize that. By signing in, because I don't think I have an account. What do we use to sign in? Let's use GitHub. Please don't make me, no, I'm not going to use GitHub. Sometimes the two-factor authorization. Okay, I'm not going to get angry at the fact that Google assumes that I want everything to be Arabic. I don't. Nothing, and go. My username __. There we go. Well, what else am I supposed to do? Wait, why can't I? I need to have a company or institution? I don't. I'm just gonna write none. Yay. 뭐야. I don't have an organization, my man. I can't skip? Oh, I can. Okay. Oh, oops, there's an ad break. I could not snooze. Sorry about that. Copying my API, putting it in the place where you put secret stuff. What is this called? W and B. There we go. Each time I read it like 1 dB. I don't know why. And then I can use it. Yay. Pasting it. Huh? Shoot. There. I did it. Well, you can still see some of it. Anyway. All right. Training has officially started. Yay. Yeah, I have used weights and biases before, so it's fun. Whoops. I just want to see our project, so let's look at our project. What do I do? Get me out of here and show me my projects. Whoops. I'm not a team. Why are you giving me trials? Downgrade. Yes. Thank you. There we go. Now where are my projects? Projects. Is that a project? I think so. Cool. We have a project. And nothing is logged yet. And this is our project. Oh, okay. That's all we have. System usage. No? Yes? Runs. Yeah, we can see it. If you press this, you hide it, but yeah. Okay. Yeah, nothing is logged yet. So that should do that. And then we can go to class. It's been a while. I miss class. Yeah. Refresh and have class start. Yeah, I agree with you. I would let someone follow the training. Oh, you're saying, okay. Would it? I don't know. If they paused the video and transcribed it. But it's not the whole thing. Is it possible? Maybe wait for the ad break to end. That's a good idea. We have 15 seconds. 10, 9, 8. All right, let's do that. And then check if anything, I doubt there are metrics set. I'll have to like allow an epoch at least. Huh? What? Sometimes there are like 3? Oh wow, sure. I don't mind resting. Why is this there? Okay. How do I check for a minute? Let me put a timer on my watch. Or yeah, not a timer, just a time lapse thing. Yesterday I was thinking about the word lapse, and like lapse in judgment, time lapse. What else is it used for? Oh yeah, but that's wrong. How many laps you can run? But it sounds the same. Yeah. That's just a lap, no? Anyway. Okay. Coffee, some coffee. And 45 seconds have passed, so we shall continue. Nice break. So this class is about feedback, learning from feedback, like human feedback, but also reinforcement learning. Homophones are weird. Yes, especially when it's from a different language.
Cool. Then the final thing, all of the automatic evaluation methods that I talked about now are trying to match human preferences, but that's not the only thing that you necessarily want to do. The final thing that you might want to do is use the model outputs in a downstream system and see whether they are effective for that. So there's two concepts of intrinsic evaluation and extrinsic evaluation. So intrinsic evaluation evaluates the quality of the output itself. And so
you guys have heard of motivation, like intrinsic and extrinsic. Yeah. So I guess models need to get motivated or evaluated.
Evaluation evaluates the quality of the output itself. And so that would be like asking a human directly about how good is this output. Extrinsic evaluation is evaluating output quality by its utility. And so just to give one example, if you can evaluate large language model summaries through question answering accuracy. And so you can take the output of an LLM and feed it through a question answering model and see whether you're able to answer questions based on this. And that kind of gives you a better idea of whether the summary incorporates requisite information. But if you think about anything an LLM can be used for, usually it's part of a bigger system, so you can evaluate it as part of that bigger system. The problem with this is it's a very indirect way of assessing things. So like, let's say your QA model is just bad. How can you disentangle the effect of the LLM summary versus the QA model? That's not a trivial thing to do. So ideally, like a combination of these two is probably the best way to go about things. Cool. So yeah. Yeah, I wouldn't necessarily say it's harder to do. It might even be easier to do, which is like, let's say, let me see if I can come up with a good example. Let's say you are trying to.
Yes.
Let's say you're trying to guess whether
the person is loading right now.
Let's say you're trying to guess whether someone will be hired at a company or not based on an LLM generated summary of their qualifications for a position or something like that.
Mm-hmm.
And actually, maybe this is not a great example because whether you should be doing this ethically is a little bit unclear.
No.
But let's say you were doing let's say you were doing something like that, just because it's the one example I can think of right now. Whether they will get hired or not is clear because you have a objective answer, right? Whether they were hired or not.
Okay.
Or maybe another example would be like, let's say
it's like you categorize them hired, not hired. It's not a range, it's not gray.
Let's say you want to predict the diagnosis in a medical application based on an LLM generated summary of somebody's LLM generated summary of somebody's, past medical history and all this stuff. And here you want the LLM generated summary. You definitely want the summary because the summary is going to be viewed by a doctor who will make the final decision.
Mm-hmm.
But you also have information about the diagnoses of all the people in your medical system later because, they went through your medical system for years and, later, like through lots of tests and stuff, how they were diagnosed. So you generate an LLM-based summary, and then you predict the diagnosis from the summary. So there, the evaluation of the diagnosis is very clear because you kind of have a gold standard answer. But the intrinsic evaluation of whether it's a good summary or not is not as clear because you'd have to ask doctors whether it's a good and understandable summary. So the extrinsic evaluation might be easier because it's clearer. So there are cases like that. The problem is you would have to have that data in order to be able to do that. Yeah.
Isn't it regards to like evaluation?
Yeah.
I was just wondering, like, typically do you just take the mean like if you think the NLP takes average, or like how do you accommodate the diversity?
Oh yeah, that's a great question. So how do you get these scores here? There's a number of different things. In the WMT shared tasks, what they did is the first thing they do is they normalize by annotator. And what they do is they basically take the Z-score or Z-score of the human annotator's actual score.
Why did he correct himself from saying Z to Z? I used to have a joke fight with my one of my lecturers where I would say Z and he was like, no, it's Z. And I was like, no, it's Z. It was fun. I guess he got his master's somewhere around Europe.
Because some people are more harsh than other people. And so what that means is you basically normalize to have zero mean and unit variance. And then after they've normalized to zero mean and unit variance, then I think they average together different humans. So then how do you deal with the fact that humans disagree on things? And I think it's pretty varied. I don't know if there's any gold standard way of doing it, but sometimes you just average. Sometimes you throw away examples where humans disagree a lot, because like you can't get the humans to agree. How could you expect a machine to do well?
That would be funny. Yeah, UK versus US, exactly. Yeah. I remember when I decided I want my accent to sound US. Well, I don't remember exactly, but oh, no, he did not though. He said Z and then Z, which he corrected himself to sound British, which I found weird. I mean, who cares? Why am I overanalyzing this? Yeah, sometimes I make comments where comments should not be made.
Get the humans to agree. How can you expect?
Yeah, I was about to say this is really interesting research, like what do you do when, I'm sure there are papers about this, but this sounds really interesting. Like, how do you evaluate? Because like, even I haven't read about it, but like, I'm curious how current generative language models get evaluated because it's messy, like I'm sure you guys have seen the scores. I was looking into Claude Sonnet the other day for some reason, and I saw like scores for math for, I don't know, like who scored them? Was there an standardized test that Claude Sonnet took? I guess that would be a good one, standardized test for generative LLMs.
How could you expect a machine to do well? So I think
the same that humans take. Yeah, because I guess they say it passes this level of math, this level of, I don't know, whatever subject. So I guess it is. I should read into it and not make guesses.
is a little bit test dependent.
So for code generation, would that have a both intrinsic and extrinsic qualities?
Yeah, so for code generation, I love this example because I've worked on code generation. A lot of people only think about extrinsic evaluation of code generation, or I don't know if it's extrinsic, but only think about execution-based evaluation of code generation, which is like you execute the code, you see whether it passes unit tests and other things like this. But in reality, actually, there's a lot of other important things for code, like readability and other stuff like that. And you should be evaluating those things, but I think a lot of people like kind of ignore that. So there are a few papers that do that, but most of the time people are just
I don't know if you guys have used any of the current chat models, but like they were really good at writing code comments. Like I would never. For me, I get confused as which is the correct one. Yeah, more effort to go Z. Oh, wait, which one takes more effort? Z is more effort. Yeah. No, I've said it before and I'll say it again. The English that we studied at school is all UK based. So like I had to like change. I mean, not that much, but because the media that I was consuming is all American, that's why. North American. Who speak lesser of, really? Huh. I mean, I guess they never had to study. Yeah, because the media I consumed, the internet videos I watched, all American, North American, and then actually I've watched some Australian stuff as well. Yeah. And what I was studying was all British, so I can't think of like many examples where I felt, yeah, like, yeah, just a few, not many, where I felt like my pronunciation was different from the teachers. Yeah, I will stop here. Okay. Yeah, because like some of my teachers were old enough to not have had a lot of media consumed, and they have, normal human accents, and I would try to sound like native people, so we would sound different anyways. Yes. Yeah. Okay, I actually have a comment. The other day down to media, yeah, almost everyone from outside US is exposed to US. Yep. That's to the though apparently there are some concerns with Bluey. Oh my god. I really like Bluey. Yeah. At least it's better than the shrimp on the Barbie stuff. So Bobby, not Barbie, you know what I mean. Yeah. At least it's a good representation. But the other day I saw a reel on Instagram about like it was a question, it was a British program, something about intelligence, I don't know, asking where has the most French speakers, and they were like, not Paris, and then the answer was Congo, and they were asking, I think, city, so, and then the most English speakers, I think it was Mumbai. So yeah, like you would think a city in the United States, because like New York is, I don't know how many people there are, but I guess they cannot win against India. So that was a bit surprising for me. The numbers were surprising. Yeah, but like it's city, not country, but still. Yeah. It's not a good thing, not a bad thing. Like maybe I see it as a bad thing, but also neutral enough. Because we need to communicate and understand each other. Yeah. But like, yeah. I guess it's good because it's the most number of speakers does not mean native speakers. Those people speak a few languages. So that's the good part. Yeah. But colonization has gone pretty far. Oh, might win for a country as well. Maybe. I don't know. I know North America, the United States has like, is it 400 million? Last time I checked, it was 300 something. Which you're right, India might win for country as well. Okay. I actually understand the intrinsic and extrinsic one better with the code generation example. Speaking of which, have we gone anywhere? We need 4 hours, making sure not to close my laptop. Oh wow, we're just doing one epoch. That's very little. Yeah.
So,
Really? From India who speak English count as native speakers? I don't know what that means. Because I know, like, Sarah? Is that the cartoon? What is the name of the whole thing? The prince? The princess? Sarah, the princess, something. Princess Sarah. Oh, no, not, does it have a different name? She, was born and grew up in India. Does it have a different name? A Little Prince, okay, maybe that. A Little Princess Sarah. I don't know if you guys have seen this. I love this. Yeah. So there are people who grew up, Lovely Sarah? How many names does this have? Is this a book? Yeah. No? Yeah, there. This is the book. A Little Princess. Okay. Okay. This group is a language being spoken commonly around. Ah. Yeah. I mean, yeah. Would that, but like if you grew up with multiple languages being all around you. Yeah. Wouldn't one just be dominating? I don't know. Oh, wrong tab. Okay. But if it's the only language and you live in a community, a close community, then yeah. Okay.
there are a few papers that do that, but most of the time people just execute the code as unit tests, unit tests. Cool. Okay. So yeah, moving on to the learning part. So now I'd like to talk about learning. And
I mind it. Thank you for the comment. Yes.
the first thing I'll cover is error and risk. And so basically, the way we calculate error is we generate an output and we calculate its badness. And so generating the output could be argmax, it could be sampling, it could be anything else like that. And we calculate its badness, which is 1 minus which could be like how bad is the output if you have a badness measure, or it could be 1 minus the evaluation score to calculate its badness. And this is defined as.
I'm like, why are we saying badness? Isn't there a better word for it? But he's like actually explaining what error means. Okay, fair. Sounds funny.
Error. And generally what you want to do is you want to minimize error. Because in the end, you're going to be deploying a system that outputs, one thing, and you're going to want that to be as good a thing as possible. But the problem with this is there's no easy way to actually optimize this value especially in a text generation style setting, but even in the classification setting, we can't easily maximize error because if you look at
Why would we maximize error? What happened? Does he mean minimize?
If you look at the surface,
It would actually be interesting if we tried to maximize error.
Of error, at some point you're going to have a non-differentiable part when you take the argmax, and
okay, like he actually said error this time and not error. See, the closed captioning also picked up error. Not my fault.
At some point you're going to have a non-differentiable part when you take the argmax, or when you do sampling or anything like that. So you're not going to be able to do gradient-based optimization. So what we do normally is we instead calculate something called risk.
Okay.
And what risk looks like is, we talked a little bit about minimum base risk for decoding, but this is for training time. And what it looks like is it's essentially the expected error of the output. And the expected error of the output includes a probability in the objective function here. And that probability.
Yeah, why not? Oh, wait, you're saying, there should be a metric for it as well, yeah. As maximally bad as possible.
Probability is differentiable, basically. So we can. There
really should be like some sort of competition where you try to have your model be as bad, but not in a lazy way. Like my model can just not give output. Okay, that's pretty lazy. My model just gives rule-based output. That's pretty lazy, but it has to be comically bad. That would be fun.
Easily do gradient-based optimization from it through it. The problem with this is it's differentiable, but for text generation, for example, the sum is intractable because we have a combinatorially large number of potential outputs. Because, if this is, we've talked about this before, but if this is like length, 50 and we have a 30,000 vocabulary, that's 30,000 to the 50 possibilities. We can't take a sum over that many possibilities. So minimum risk training tries to minimize risk. Reinforcement learning, also many of the models, especially policy gradient models, are trying to minimize risk as well. So, but the reason why I wanted to talk about risk first is because this is very simple to get to from the point of view of like all the things that we've studied so far. So I think it's worth talking about that.
Really? It happened with GPT-2? How? I don't think I've heard about that. An experiment that made it maximally bad. That's...
Talking about that. One other thing that I should mention about is, or no, sorry, I'll talk about that later. So when we want to optimize risk, what we do is we sample in order to make this tractable. So a very simple way to minimize risk is instead of...
okay, I see. I see. I tried to put the link somewhere. See, now it goes to the different tab. single minus sign led it to give a bad output. Interesting. This is really interesting. Is this a whole video or yeah, okay, this is a link for a video. I think I'm gonna watch it. I have not heard or seen this. Thank you. Appreciate that. Thank you for the tag. You guys can also watch it on your own time. I'm not gonna watch it right now. Yeah. Thank you. That is really interesting. And I suggest you, if you feel like it, you can even put it on Discord. I don't mind it.
So a very simple way to minimize risk is
We can put it in the links during stream channel. That one. Ooh, it's EA propaganda. I like EA. I don't have any information about anything gaming. I've just played Harry Potter games and it was made by EA. That is the only thing I know about EA. I wouldn't take it seriously. Okay, all right. I thought it was a normal YouTube video because the thumbnail looked like a normal person. I'm not sure. Sampling for tractability. Tractability, okay.
to make this tractable. So a very simple way to minimize risk is instead of summing over all of the possible outputs, we sum over a small number of possible outputs and we upweight. Sorry.
Oh my god, I'm sorry. See, I didn't know what it meant. Effective altruism. Huh? Not. The other EA stands for Electronic Arts. See, I didn't even know that. And I'm not sure if I know what effective altruism means, but I've heard it way too many times. Has to do with advocates impartially calculating benefits and prioritizing causes to provide the greatest good. Using evidence and reason to figure out how to benefit others as much as possible and taking action on that basis. Is that a bad thing? I don't have enough information. Impartially. Okay, the impartially part is not a good thing, I think. I don't know what that, I don't know. Huh? Okay, now I'm fully lost. We're in an ad break, by the way. It's a full minute ad break, according to Discord. What is that? That's a name, so I'm gonna Google it. They are a computer science researcher. And okay. Oh, see, now I get it. Sorry. Got it. Okay. He's the one that wrote Harry Potter and the something philosophy. Oh, nope. Something rationality. No? Yep. Methods of rationality. There we go. Got it. Okay. All right. Yeah, their current comments are mostly AI. Cool. creating a sample of sentences and calculating risk for that.
Instead of summing over all of the possible outputs, we sum over a small number of possible outputs and we upweight. And we normalize to make this all add up to 1. And so this normalizer here is basically the sum over all of the probabilities that we have on the top part here. And these samples can be created either using sampling or n-best search. We don't need to have, from the point of view of doing this sort of minimum risk training, the kind of correct way of doing this is sampling using ancestral sampling, like we talked about before, and minimizing the output based on the samples. But the problem with that is, as many of you also might have seen when you were sampling from your language model from assignment 1, if you sample with temperature 1, it gives you a lot of like not very good outputs, right?
Mm-hmm.
And so if you're sampling with temperature 1, you'll be exploring a very large part of the space that actually isn't very good. And so because of this, some other alternatives that you can use is you can just do n-best search to find the best outputs, or you can sample with a temperature that's not 1 or something like that, and basically create a list of possible hypotheses and then normalize over them. So that's another option. And very often not using temperature 1 is a better way to do it. If you're sampling with not temperature 1 and you are potentially getting multiple outputs, you should try to deduplicate or sample without replacement, because if you get multiple outputs here, it messes up your equations if you basically have the same one in there multiple times. Cool. So this is a really simple example of how you can do minimum risk training, but now I want to get into
Before we do that, I want to see, okay. Are we going to get any metrics if you don't hit the epoch? No. Well, we can still see system usage. Power usage. Ooh. Sorry about that. There's one that does the okay. Cool. We can be here for another 20 minutes. I think that'd be pretty good. So let's see how far we can go.
Reinforcement learning, which is the framing that most modern works about this, Paula. One thing I should mention is there are actually other alternatives to learning from human feedback, including like margin-based losses and other stuff like that. But most people nowadays use reinforcement learning, so I'm only going to cover that here. So what is reinforcement learning? Reinforcement learning is learning where we have an environment, X, ability to make actions A, and get a delayed reward, R. And there's a really nice example, if you're not familiar with the basics of policy gradient by Andrei Karpathy, which I linked in the recommended reading, so you can take a look at that. But in that example gives an example of Pong, where you're playing the game Pong, where X is your observed image, A is up or down, and R is the win-loss at the end of the game. Does anyone have an idea?
Yeah, I guess why would it be the final win and loss when it can be the score? Like if your opponent does a score, then that's like, do we optimize for score or do we optimize for winning and losing? And is there a difference?
About what this looks like for any arbitrary NLP task that we might want to do reinforcement learning for. So what is X what is A and what is R?
If it's just numbers, yeah. If it's an image, it's like, does the word image mean an actual image, or does it mean like a snapshot of the moment? And we're talking about NLP, right? So it's just text.
Pick your favorite.
Whoa, original Pong didn't have a score? Sum of wins. Huh. Really? Intention is to think about sparse rewards. Okay. Because it says delayed reward. That's why it's like at the end of the game and not right now.
Awesome. Anybody? Yep.
A could be the next person.
Or what's X first? Yeah.
Like, what you have generated so far.
Okay.
And then A is the next person.
Okay.
Or it could be like the button the user click on whether or not you're out of security.
Okay. Yeah, I think this is very close. Just to repeat, it's like X is what you've generated so far, A is the next token, and R is the button that the user clicks about whether it's good or not. I think that's reasonably good, although I don't know if we'd expect them to click the button every token we generate, right? So it might be that X is the conversational history up till this point. A could be a next token generation, and then R is a reward we get in an arbitrary time point. It might not be like immediately after generating the next token, but it might be later. And that's actually really, really important from the point of view of reinforcement learning. And I'll talk about that in a second. Anyone have an idea from, I don't know, code generation or translation or some other things? Yeah.
For code generation, maybe actually the compiler or like the graphic script. And then the action is the actual code that it writes, and the reward is whether it passes in the front.
Yep. So X could be the compiler. It's probably the compiler and all of the surrounding code context, like what is the natural language
IDE
output, and it's also what is the project that you're working on and stuff like that. A, I think typically we would treat each token in the code to be an action.
Okay.
And then R would be the reward after a long sequence of actions. And it could be the...
So for translation, environment would be source, action would be target, and reward would be, if it makes sense.
Reward from the compiler. It could be the reward from a code readability model. It could be the reward from a speed, execution speed, and stuff like that. So like one of the interesting things about R is you can be really creative about how you form R, which is not easy to do if you're just doing maximum likelihood also. So you can come up with a R that really matches with like what you want in an output. So why reinforcement learning in NLP? And I think there's basically three answers. The first one is you have a typical reinforcement learning scenario where you have a dialogue where you get lots of responses and then you get a reward at the end. So the thumbs up and thumbs down from humans is a very typical example of reinforcement learning because you get a delayed reward at some point in the dialogue when a human presses up or down. Another, like actually more technical scenario where reinforcement learning has been used for a long time is call centers. So we've had dialogue systems for call centers. And then if you complete a ticket purchase or you resolve a ticket without ever having to go to a human operator, you get a really big reward.
Wow.
If you have to go to the human operator, you get maybe a smaller reward. And if the person yells at you and hangs up, then you get a really negative reward. Okay,
so apparently hangs up is not a negative reward, but yelling and hanging up, that's pretty negative. I don't think I've ever had a automated thing resolve my problem. Like I always go for the human. Humans need to have jobs as well.
So this is kind of the typical example. Reinforcement learning has been used for a long time there. Another example is if you have like latent variables, chains of thought, where you decide the latent variable and then get a reward. You get a reward based on how those latent variables affect the output. So this is another example, because the chain of thought itself might not actually be good. You might have a bad chain of thought and still get the correct answer. So you don't actually know for sure that a chain of thought that was automatically generated is good or not. But that kind of makes it a reinforcement learning problem. And another thing is you might have a sequence level evaluation metric, so that you can't optimize the evaluation metric without first generating the whole sequence. So that would be any of the evaluation metrics that I talked about before. So these are 3 scenarios where you can use reinforcement learning. So I'm going to make a few steps through, but let's start again with our supervised MLE loss. And that's just the log probability here. In the context of reinforcement learning, this is also called imitation learning because essentially you're learning how to perform actions by imitating a teacher.
They don't try hard with automated customer service systems. Just having an idea and having already Googled for help means that you have read this random documentation page. Yeah, I mean, I don't know if we have a good one, because there are better ways to make it may not even be related to my issue. Yeah, stands no chance of being helpful. Most of the time the automated one just gives me my choices. Like if you're interested in our packages, like no, I'm calling because of an issue. So yeah, if you want to be connected to a human operator, press this. Just giving me my options. That's the only time I have talked with a non-human being. Yeah, I think there are really better ways to humanize your documentation, like having a text-to-speech model that says, hello, you're talking to a text-to-speech model or to a robot. I can take your problem and try to find a solution based on the documentation. But if you want to talk to a human operator, press this. That would be really not bad, because I think a normal percentage of humans that are not interested in talking to another human being might not find problem with this. Like if I'm talking to a LLM style, but you know what? I don't know, because I don't know if you guys saw the recent video that Charlie from Moist Critical made about the guy that took their life, the kid. So yeah, that also should be really monitored. Yeah, that is really sad. Okay, I'm sad now.
Because essentially you're learning how to perform actions by imitating a teacher. And imitation learning is not just supervised MLE. There's also other varieties of imitation learning, but this is one variety of imitation learning. The next thing I'd like to talk about is self-training. And basically self-training, the idea is that you sample or argmax according to the current model. So you have your current model and you get a sample from it. And then you use this sample or samples to maximize likelihood. So basically, instead of doing maximum likelihood with respect to a gold standard output, you're doing it with respect to your own output. So does this seem like a good idea?
Why not? Wasn't AlphaGo playing against itself? Isn't that the same idea?
I see.
Yeah, a few other YouTubers made a video about it, but I can send you the first video that I watched about it.
A few people shaking heads. Any ideas why this is not a good idea? Yeah.
One is like reading, two, it's like can't even check how it's good necessarily if you don't have some external access to it. That's good, but no, but anyway,
Yeah, exactly. So if you don't have any access to any notion what's good,
Oh,
this will be optimizing towards good outputs and bad outputs, right? So your model might be outputting bad outputs and you're just reinforcing the errors that the model had already. Nonetheless, like self-training actually improves your accuracy somewhat in some cases. Like, for example, if your model is right more often than not, basically optimizing towards the more often than not right outputs can actually
here's the link to the video. Yeah. Yep. Oh, did I? Oh, I think I messed the link up. No, I'm trying to clean it. Okay.
due to the implicit regularization that models have in early stopping and other things like that, it can actually move you in the right direction and improve accuracy. So there are alternatives to this that further improve accuracy. So like, for example, if you have multiple models and you only generate sentences where the models agree, then this can improve your overall accuracy further. This is called code training. It was actually created by people at CMU as well. And another successful
Wow. 1998. My question is, if we don't give any directions and just let it do something, will it? Because I'm sure you guys have seen the videos where a model with a human shape, 3D thing, runs and it's optimized running in a different way. So I feel like it can find something and stick to it and make it as optimized as possible and be weird and funny for us.
Is adding noise to the input to match the noise that you find in the output. So if you add like word-based dropout or other things like that, this can also help accommodate these things. But anyway, so self-training is useful, but there are better alternatives if you can get a reward function. So the simplest variety of this is something called policy gradient or reinforce, or more specifically reinforce. And basically what this does is this adds a term that scales the loss by the reward. So if you can get a reward for each output, basically this, instead of doing self-training entirely by itself, you multiply it by a reward. And this allows you to increase the likelihood of things that get a high reward, decrease the likelihood of things that get a low reward. So a brief quiz here. Under what conditions?
Oh no, quiz. I was zoning out, sorry. Code training maybe biases toward a kind of likely and not noise direction. Okay. Yeah, I mean you have to give it a direction. Otherwise you don't know what it is. And that might be fun, but I don't think there's enough funding in AI for fun.
Is this equivalent to MLE, or essentially equivalent to maximum likelihood estimation. And so like in order to make this quiz easier, I'll go back to maximum likelihood estimation. So it looked a bit like this. You calculated the log probability of the true output. And now let me go to here. Any ideas?
If this is 1?
When your reward equals to 1, sometimes and 0 other times. What? Any ideas? When does your reward need to be equal to 1 in order to make this equation
If they did
equivalent
perfect,
equation.
is 1 100?
Yeah, when y and y hat are the same. So basically, this objective is equivalent to the MLE objective when you're using a 0-1 loss, where you're using an evaluation function that gives you a score of 1 when it's exact match and 0 when it's not exact match. So, but that also demonstrates that this can be more flexible because you can have other rewards that are not just 1 and 0 for exact match, but you can use things that give you partial credit. You can use things that upweight multiple potentially correct outputs and other things like that. So one problem with these methods is how do we know which action led to the reward? So the best scenario is after each action, you get a reward. So after each token that you generated, you get a thumbs up or thumbs down.
But that's not easy, right? That's why we don't do this. We make it sparse.
From the user about whether they like that token or not. And how much happier they are after you generated that token than they were before you generated that token. The problem with this is that that's completely infeasible, right? Like every time after you use ChatGPT, you're not going to press thumbs up and thumbs down after each token. So in reality, what we get is usually we get it at the end of rollout of many, many different actions.
Oh, we get a total score. Okay. I'm checking. I need to watch another 5 minutes for it to make sense for me to stop. So I'll do that. I still have time.
And we're not sure which action is responsible for giving us the reward. And so there's a few typical ways of dealing with this. The most typical way of dealing with this right now is just not dealing with it. And just hoping that your optimization algorithm internally will be able to do credit assignment. And so what that entails is essentially you give an equal reward for each token in the output. Other ways that you can deal with it are you can assign decaying rewards from future events. So like, let's say you're talking about a chatbot, for example. Maybe this is the most kind of intuitive way of thinking about it, but you have a chatbot, you have like 20 chat turns, and you have the user give a thumbs up or a thumbs down on the 20th chat turn. There you would assign a reward of like, let's say it gave a thumbs up. There you would assign a reward of 1 for the previous chat turn, a reward of like 0.5 for the second previous chat turn, a reward of 0.25 for the third.
Oh, I was about to say like give equal amounts to the 20. If the thumbs up is for the whole 20, but how do we know?
Previous chat turn to basically say, yeah, like the user is feeling good at the moment they gave the thumbs up, and that's probably more likely due to the thing.
Okay. So the user doesn't know that we are checking, so they just give a thumbs up whenever, because I've done that. I've given thumbs up to answers that ChatGPT gives me, and it says, give me a comment. I'm like, you know what? Forget my thumbs up. I'm not going to give you a comment. That makes sense to say, okay, this is the most important part, but also maybe a few other answers.
Things that happened recently. So, yeah.
We have a predetermined reward model, like we're not learning the reward.
So the reward model can be any of the methods that I talked about before. So it can be human feedback directly, like a thumbs up or a thumbs down. It could also be from a reward model that was pre-trained. You could also theoretically learn the reward model simultaneously, but you'd have to simultaneously with the model itself. So yeah, I'm going to talk a little bit about DPO, which kind of does that a little bit, but I would basically say that wherever you're getting your reward is probably from one of the things I talked about earlier today. Cool. Any other questions? Okay. So that's the basic idea. The very simplest thing that you can do is you can just sample, optimize the subjective function, this is dead easy. It's not hard to implement at all as long as you have some source of reward signal. But the problem is reinforcement learning can be very unstable, and it's hard to get it to work properly if you don't do some additional tricks. So I'd like to talk about this next. Yeah, sorry. Yeah. Yeah, the typical way is you just have an exponential decay. So you multiply each time by like 0.5 or 0.9 or something like that. From A6 to 1. Cool. Okay.
Nice.
So
we pause here, right?
And that's one option. And
Okay.
sorry, just to clarify, the most common option nowadays, at least from the point of view of models, is not to decay it at all and just assign the same amount for each token.
Mm-hmm.
I'm not actually 100% sure what people are doing with respect to like long chat things. I think probably they're only assigning it to the current like utterance and then not optimizing the previous utterances. So like if they get a thumbs up or thumbs down signal, then they would assign an equivalent reward for all of the tokens in the current utterance and 0 reward for the previous ones. But I'm not 100% sure about that. There might be other methods that people are using.
That's it. Okay. 1 hour, 10 seconds. We clock the time and then we
Cool.
pause it. And that means we'll have 15 minutes for the next stream. That was our training going. It has been training for almost an hour. And it has another 3 hours remaining, meaning I should not close the lid. So I will not close the lid. There's an ad upcoming in 20 seconds. Yeah. We learned today that sometimes abbreviations are not always what they seem. MLM does not mean multi-level marketing, and EA might not mean the gaming company. Yeah. Okay. I'm glad that I was able to stream today because sometimes I can't. So thank you for joining me. That was nice. I had a nice time. I have, unsurprisingly, I mean, very surprisingly, I actually posted a short yesterday, so I'm proud of that. Yay me. I'm trying to find an easy way to clip, stream things and post them. And my current method is to write down the time when I think I said something that is clip worthy. But yeah, thank you. I think the audience can also clip the conversation, depending if they feel like it. I tried doing the clipping myself and I failed. So yeah. During the stream, I mean. So it's better to do it after. Yeah. Okay. So thank you so much for being here. Whether it's on Twitch or YouTube. If you'd like to hang around, you can either, be here on Twitch or YouTube or anywhere else on the social medias. It's linked somewhere. We're also on Discord. Yeah, you can get notified if you'd like to join the next stream. Because yeah, if you don't, that is normal. You're a normal human being. Okay. Inshallah, we'll continue with this learning, and I feel like I'm understanding things. Like I used to think that I am not understanding things. Now I think I'm understanding at a maybe like 50% level. So I'm really proud of myself for that. I've come a long way. Yeah. So I wish you a lovely weekend and see you next time, whether it's in short form or live stream form, whichever it is. Yeah, I'm gonna end the stream in 5. countdown of 5. If there's anything else, let me know. Otherwise, have a lovely day. Okay. Why am I looking to the side? I don't know. Okay. 5, 4, 3, 2, and 1. Thank you.